Okay, I'm going to be honest here. I'm not going to really be explaining so much in this batch of assignments as I am going to blast my way through them because I'm working under the assumption that you've seen the other videos already and you know what to do. I'm going to try to combine the homework and the quiz into one. All right. What's the hypotenuse here? The hypotenuse is AB, which is letter B. That's easy. The adjacent of A. Okay, the adjacent of A is that's the apportionation I needed. That's AC. That's gonna be letter C, and this was BA. Submit. Okay. Next question. These are very straightforward. The problem that I'm having is that I'm noticing that the quizzes come up with questions that you've never seen before. So I want to be able to trap them when they show up. In a triangle ABC, what is the sine of B? Sine of B is 9 over 10. Click that and submit. And again, if you're curious about what the reasons are, the earlier video does explain it. I don't intend to explain this time. I just want you to follow along with me. All right. Which ratio would it be? It would be the opposite over hypotenuse sine. Okay. And okay, this is easy. Sine is the opposite over the hypotenuse, which is letter D. Tangent is opposite over adjacent, which is letter A. Cosine is adjacent over hypotenuse, which is letter B. Wait, that can't be right. Opposite over adjacent. Opposite over hypotenuse. Opposite over hypotenuse is letter D. Okay. Almost made a mistake there. I didn't. So, all right. What do we have here? The sine of A is opposite 7 over hypotenuse 11. And that would be the last one. The reason it's not 9 over 11, because that's the adjacent. However, I must say that the sine of B would have been 9 over 11, but the sine of A is 7 over 11. So submit. Okay, so far so good. We're almost done with this. Which trig function would you use in this case? Adjacent over hypotenuse or cosine. Submit. Next one and last one. Again, trig ratio. These are super easy, really. There's nothing to blast you out of the water here. Opposite over hypotenuse is letter C. Cosine is adjacent over hypotenuse, which is letter E. And I think that's it. Let's see. There is no next question because we have completed all the questions. So I think you'll agree this is an easy problem set. So I don't want to really spend too much time on this one, but I do want to look at any tricks that the quizzes might contain because I did not like that. 3 questions. So I don't know. Maybe it shouldn't be that bad. We'll see. No. I'm gonna start this from scratch. I'm gonna exit. Okay, I'm gonna go back to it because I just don't trust it. The quiz for right triangle trigonometry. Here we go. All right, let me reset it before I open it up. Let me go start. All right, what does it got here? Okay, if B is 45 degrees and C is 13, what is A? Okay, well, A must be 45 degrees for reasons that I described when I talked about sexual right triangles, and I hope that made sense to you when we did that one. Now, in terms of what C is, if C is the hypotenuse is 13, I will explain this one just because it's useful now that we know a little bit more than we did before. The important thing to take away from here is that if you remember what we did before, we could have done, for example, the cosine of 45 is equal to the opposite over the hypotenuse, and that would give us our answer. Okay, B would be 13 cosine of 45. So B would be this. But I do want to mention that you know that if this is 13, then that must be like A or B times radical 2. Okay? And if I know that B radical 2 equals 13 if B is equal to 13 over radical 2. So quick pop into the calculator to do this one. Let's see. Let's go to it. 13 divided by the square root of 2. And that'll give me 9.19. So that's going to be our answer. Oh, it wants the exact value, so it wants a square root. So it's 13 over radical 2, or 13 radical 2 over 2. Remember that too. Let's confirm that one. 13 radical 2 divided by 2, we get the exact same thing. But I do want to do 13 cosine of 45 to show you what's going to happen. 13 cosine of 45, and maybe it's the most straightforward way this time around. You get the exact same thing, 9.19. But they do want 13 radical 2 over 2, I guess. Let me see. Cosine b, yeah, okay. Well, I'm going to do 13 radical 2 over 2. 13 square root of 2 divided by 2. That should work. Let's see. It did. I wonder if it takes 13 over radical 2. I guess I'll never find out because it won't let me put the answer back in once I finished it. But it might have worked. I'll never know. So moving on. And again, once you know, again, the special right triangles, not similar. Once I have special right triangles really locked in, these are really easy to do. Okay, which trig function would you use in this case? I would use the opposite over the adjacent or the tangent. Move on. Next question. What is the tangent of A? I need to figure out that A is here. Opposite over adjacent would be 3 over 4. Not the decimal value. It wants the fraction value. And that's it. I think I'm done with this too. So, okay. Well, I guess it didn't really cost me as much as I thought it was going to do this one. And I'm still only 6 minutes in. So I'm feeling a little bit reckless right now. So I might do solving right triangles with this one too. 9 questions. Oh, boy. All right. Let's go for it. Okay, let's just solve it really quickly. I'm going to do the proportion right away and then solve right away. I'm not even going to read the question because I know it wants 2 decimal places. That's the important thing here. This is my angle, adjacent over hypotenuse. The cosine of 14 is equal to x over 8. So when I get that, I'm going to put that answer here. So 8 cosine of 14. 8 cosine of 14 is equal to 7.76. 7.76. Boom-a-loom. Got this. I don't know where that came from. Sorry. Here we go. Same kind of problem. And again, these become really easy. Opposite over hypotenuse. Opposite over hypotenuse. Sine of 38 degrees equals x over 11. So once again, the same structure. Do the same thing. 11 sine of 38 equals 6.77. 6.77. Hit it. Move on. Again, once they get really easy, it's like there's nothing to it. Find the length of x. They want us to find the length of x. Same thing. Opposite over adjacent. This is a tangent problem. Tangent of 34 equals x over 12. Once again, the same structure. I'm going to do the same structure here too. Let me get out of here. 12 tangent of 34 equals 8.09. That's what we're going to put here. Boom. Okay. 6 more. Okay. Let's see what happens now. Suppose A is 8. Okay. Let me make it red so it pops out against the background here. If A is 8 and B and C is 10, this will be 6. I'll tell you why. Because this is simply the 3, 4, 5 triangle multiplied by 2. And they do that a lot. They disguise this basic triangle by multiplying it up by 2 or by 10 or by 3. But once you spot it, they're easy to solve because now we know that B is equal to 6. And if nothing else, that's easy. We can do that one. Now we do have a challenge because now we're going to have to figure out what the angles are that created those. So I'm going to do, say, A. I can pick sine, cosine, and tangent. I guess I'll do tangent just to prove that it'll work. And that'll require me to do the tangent of A is equal to 8 over 6, right? 8 over 6, which is 4 over 3. But it doesn't tell me what the angle is. So I'm going to have to use the inverse tangent function to get this, to get A. All right, so, and remember to do that in calculator. You have to go to not tangent, but inverse tangent, and give it that proportion, 4 divided by 3. And that'll give you 53 degrees. 53.13. I'm going to write that down because I'm going to need it in a second. 53.13. And then I'm going to subtract 90 from that to figure out the complement, which is the other angle, 36.87. And if I do 36.87, rounding off correctly, this becomes a 0, 0. This becomes a 0. This becomes a 9. So that's correct. So we know that A is now 53.13 degrees. And B is 36.87 degrees. That should be it. I think that's all it was. But, oh, hell no. I don't want that. There we go. Okay, we got that right. I think you'll agree these are easy. Next question. Okay. Angle of elevation problem. So I need to draw my picture. I need to use black to show it. The angle of elevation to the top of a building, whoa, okay, is 2 degrees from the ground. I know why, because I put highlighter. From the base of the building. Okay, 2 miles, 5280 times 2. All right, let me just not take any chances. 5280 times 2. So my base is 10,560. Let me make it the actual size now. 10,560. This is 2 degrees. I'm looking for this. Opposite over adjacent. Tangent. The tangent of 2 degrees equals y over 10560. It does bear noting that this is a really small angle, so this will not be a major height, right? But we are 2 miles away from it, so let's see. Okay, let's do it. 10560 times the tangent of 2 should not be that tall. Okay, it's 368 feet tall. 368.76 feet tall. Counts. Round to the 10th, though. Only 1 decimal place. 368.8, because somebody's being mean. 368.8. Okay, we got that right. Where are we? 6. 6. All right, here we go. Angle, ladder problems. The ladders, of course, the ladders. So I'm going to draw, oh, it's in white. Let me fix that. Ladder, street, or ground, building. Okay, the proper angle for a ladder is about 75 degrees from the ground. And we have a 29-foot ladder. Sure, why not? 29 feet. And they want to know how far from the base of the ladder should we do it. So we need this one. Adjacent, hypotenuse, cosine. Cosine of 75 degrees is equal to x over 29. So we're going to put that in. 29. Cosine of 75. 7.51 in this case. 7.51. Boom. Okay, we're at 7. Again with the ladder. All right, fine. I can do as many ladders as you want, man. No problem. Let me do this one. Okay. And I know the ladder is 25 feet tall. 25 feet tall. Yeah, 25 feet long. 25 feet long. The angle between the ground and the ladder is 85 degrees. And they want to know how high it reaches up on the building. So opposite, hypotenuse, sine. 1 decimal place also. Remember that too. 85 is pretty high up. That's a pretty steep angle, so it's going to be really up there. Y over 25. So we're going to do that too. 25 sine of 85 equals 24.9 feet. That's pretty high up. Seriously. 24.9. Bang. We're up to 8. And again, I'm flying through this because you should pause if you're not sure, but you should have also seen the earlier video by this point. Okay, and yet another ladder problem. They don't have a lot of imagination, these guys. Okay, we have a ladder, 83 degrees. That's really high up there, something like that. Okay, and now they want 2 decimal places. They keep going back and forth about what they want, but that's okay. How high does the ladder reach? Pretty high, because this is a pretty steep angle. It also means that this is pretty close to the ground. This is 21. And I have 83 degrees, right? There's always going to be something you're missing and something you're given. Opposite over hypotenuse, sine of 83 is equal to y over 21. Let's do it. 21 sine of 83. 20.84. 20.84 to the hundreds, 2 decimal places. 20.84. And enter. All right, so far we're doing great. Haha. Let's try one more. Let's keep. Can we get through this unscathed? Okay. Oh, the radio tower problem. Yay! I love this one. We're gonna draw the ground. We're gonna draw the tower. We're gonna draw the building, and we're gonna draw you. This is you, and you can look up to the top of the tower. Let me do it horizontal here, and the angle of elevation to the top is going to be 34 degrees, and it's going to have an angle of depression, so we need that too. So we're going to put 34 degrees, and this will be 23 degrees. And just the distance, this is 375. That's common to both, right? So I'm going to change it up, and I'm going to make one violet and one blue, but I guess I don't know. We want this one, and we want this one. So let's take care of this. Now change colors. Dark blue. Okay, y1. The tangent, opposite over adjacent, yeah. The tangent of 34 degrees is equal to y1 over 375. I can do the other one too while I'm here. Let me make that dark green, yellow-green. The tangent, oh my God, I don't like that. Let me change that. I hit the wrong button. Whenever that highlighter button is there, I always tend to hit it. I don't like that. Let me get rid of that. Okay. Let me make that green. Did I make that green? I will. Here we go. The tangent of 23 degrees is equal to y2 over 375. Okay, so y1 plus y2. y1 plus y2. Oh, let's try something. y1 plus y2 is equal to 375 tangent of 34 plus 375 tangent of 23, which means I can factor it out. I just want to see if it works, you know, that's all. Tangent of 34 plus tangent of 23. I haven't been putting the degree symbols, and I really should, but okay. Let me add these up. Let's do it. Okay, 375 times, I'm going to put it literally the same way you see it here. Tangent of 34 plus the tangent of 23. That should give us our total height. We have 412 point, nearest whole foot, 412 this time. 412. Let's see if it's right. It did work. All right. So this is the end of the homework section. Revisit it for homework 26, just in case you wanted another run through with this one. I'm going to finish this one up. I hope that is making sense for you. And now I'll see 7 problems with the quiz. Again, I don't trust it, so I want to try it out. Start. The ladder again. Again, no, they really don't really think about these things. 82 degrees, that's pretty steep, so I'm going to bring it up here. I'm going to put this here, and you know they'll ask you different things, but there's really a limit to how creative they can get with these. Let me make it black. So here we go. Okay, 25, and the angle is 82, guaranteed. So they either want X or Y. In this case, they want how high does the ladder reach on a building, so they want Y. Opposite over hypotenuse. Sine of 25 degrees is equal to, 82 degrees. Y over 25. Y is equal to 25 sine of 82 degrees. Remember, not 82. You want 25. All right, let's do that one. 25 sine of 82. And do they want it to what? It doesn't say. How does it round it off? I'm going to go with 24.76 because I'm not sure. And when in doubt, go with a double rounding. 24.76. Yep. Okay, so far so good. It doesn't tell you. I don't know why it doesn't tell you what it's rounded off to, but fine, move on. Okay, the distance problem. And how many miles is it? 1 mile? All right, so that's a little bit easier. We can do this one. Empire State Building. Ooh, tall building. Yeah. And we're a mile away. We're a mile away, and 1 mile is equal to 5,000 280 feet. And we know it's to be 11 degrees. And they want to know how tall the building is. Okay, well, we're going to need to figure out this y. The opposite over the adjacent again. So tangent of 11 degrees is equal to y over 50 to 80. After a while, these aren't really even challenging at all. They're just procedural, you know what I mean? So tangent of 11, and it'll give you 1,026 feet. I don't know what it wants, so 1,026.33, just because I'm not sure. Okay, luckily it took that. Let's go on to question number 3. And this one is the survey team on the plane looking up at the mountain from 2 different locations. All right, so I'm going to actually draw the picture for this one smaller than normally because I need space to do this one. It's going to take up a lot of space, so keep that in mind. You definitely want to visualize this one though because it's complicated if you don't. All right, so I'm going to illustrate the way we did the last one. I am explaining this one because this one's a little bit more complicated than we're normally confronted with. All right, so the first thing I want to do is notice that I want to put it in black. I like black. All right, so survey team is from one point on this plane. They observe that this angle of elevation would be 26 degrees, and then when they walk 2,000 feet closer, it's going to have an angle of elevation of 29, which makes sense because they're looking up at the mountain. So as you get closer, you would have to crane your head higher. And it wants to know what the height of the mountain is. But in order to get the height of the mountain, we're going to have to get this x value. We know that the difference between this location, say A, and this location, say B, is 2,000 feet. But that's pretty much it. So we're going to set up 2 different proportions, and I'm going to highlight these in different colors. I'm going to do the yellow proportion first, and the yellow proportion would be this one here. It's this triangle here. So we're going to look at this first, and we're going to use it in the second one. So the tangent, opposite over adjacent. So the tangent of 29 degrees is equal to y over x, which doesn't do us a whole lot of good because we don't know either y or x. So we're going to have to use the other one now. We're going to use the entirety of the larger triangle. So we're going to talk about this one now. And that's a bad line. Let me fix that line. I don't like that line. Let me try it again. One more time. Let's see if this can work this time. I just got to go a little more slowly, and it might work. Yeah, here we go. All right, so we're going to use this proportion now. And we have a tangent again, but the tangent is a little bit more involved this time. The tangent of 26 degrees is the opposite, which is still y, which is good because we're going to have to link these up with the adjacent, which is 2,000 plus x. That's what we have to deal with here. But luckily, I can get y from using this setup here, and I can get y to be x times the tangent 29. X tangent 29 is equal to y. Okay, 29 is equal to y. So I'm going to replace this here with that. So I'm going to get rid of this because normally I would leave it there and write through, but I actually want to keep as much space free as I can. And that's going to give me, instead of x times the tangent of 29 over 2,000 plus x. So now we know what to do. We just have to get the x's isolated. I'm going to start by cross multiplying this and this, and that'll be 2,000 plus x. I'm going to go up here, 2,000 plus x in parentheses, because it's going to multiply. Both of them are going to multiply with the tangent of 26 equals the x times the tangent of 29 that we just got before. And you know what I haven't been doing? I haven't been using the degree symbols, but I hope you just understand that it's there. Distributive property. This looks a lot like prior work that we've done before. 2,000 tangent of 26 plus x tangent of 26 is equal to x tangent of 29. Now we're getting closer. I'm going to need to bring this over. That'll leave the 2000 tangent of 26 by itself on the left side of the equal sign. Equals. All right, now I'm going to bring it over, but I'm also going to subtract. I'm going to, not subtract, factor the x's out at the same time. It's a two-step process. I'm just combining it into one step. Tangent of 29 minus the tangent of 26 degrees. Okay, so far so good. And now x will be by itself if I divide this up. So I'm going to have finally x is equal to the 2000 tangent of 26. That's still going to be in the numerator, but the denominator of that will be tangent 29 minus tangent of 26. And as I said before, it's impossible to do this problem without a calculator. Technically, you could do it back in the old days when we didn't have calculators. We used to use charts that would give us all these values, but that took forever. It was a real pain. So I never liked doing that. So let's do this one. I'm going to do each one of these one step at a time. So I'm going to begin with 2000 tangent of 26. Okay, I get 975.47. I'm going to put that in. I'm going to store that into my x registry. So when I hit x, I get that answer. All right. And then I'm going to do tangent 29. Okay, tangent of 29 minus the tangent of 26. And just in case, I'm going to put that in there. So I'm going to get 0.066, that whole thing. I'm going to store that too. I'm going to store that in y. So when I divide x with y, I'm going to, when I divide x and y in the calculator, I'm going to get that horizontal distance that's missing here, and we're going to need that. All right, so I just want to explain to you what's going on here. So x divided by y will give me that horizontal distance of 14,000. Wow, that's a lot. I don't know. It doesn't feel right, but let's see what happens. I'm going to write this down. Actually, no, I'm not going to write it down. Well, I will, but I'm not going to write it down for the purposes of this problem. I'm actually going to do something else. So x is equal to 14,651 feet. That's a lot of feet. All right, so, well, we'll see. It might work out. We'll see. All right, so let me think about what I'm going to do now. Okay, so now I'm going to add that number. I'm going to add that value to 2,000. I'm going to add 2,000 second. That'll make up the entirety of the bottom triangle. Follow my logic here. In case I need it. I might need it. So in case I do, I'll have it. I'm going to put that in Z, just in case I need it. I actually don't 100% need it because I have enough from the yellow triangle. The tangent of 29 is already there. We can just use it to verify, I guess. But the tangent of 29 is equal to y over that 14,651 that we just got a second ago. So I'm going to use that. So it's going to be 14,651 times the tangent 29. Got to remember what I'm doing here because I'm going to have to subtract out that 2,000 that I just put in a second ago. And if I don't do it right, I'm going to end up with the wrong answer. So, okay, we're back to that. And now I'm going to multiply that by the tangent of 29. And it's going to give me a vertical height of 8,000. Oh, maybe it will fit. Okay, so it looks like y would be about 8,121, 8121.63 if I'm going to round off. And that may be all I need. That might be it. Let's see what happens. I'm going to put it in. I'm going to go here. 8121.63 feet. That seemed reasonable. Let's see. Hey, we got that right. So be careful with this one. You got to remember that when you figure out what x is here, it's not the vertical distance; it's that horizontal distance, and you do need that to get the y, the height of the mountain. Okay, this one was a little bit tricky. You might want to try one similar to it in the homeworks, but all right. Hopefully, we don't get something like that later on in a quiz or something. All right, next one is going to be question number 4. Question number 4 looks like, oh, another ladder problem, for God's sake. All right, well, I'm going to use the picture this time since they gave me a picture. This is 75 degrees from the ground, and I have a 27-foot ladder. And they want to know how high I can reach it opposite over hypotenuse, sine of 75. Sine of 75 is equal to what? Y over 27. Okay, that's easy. 27 sine 75. 27, not tangent. 27 sine of 75 will give me 26.08. 26.08. It might just take 26, but I don't want to take my chances here. 26.08, right? 26.08. All right, we got that one right. That's not that weird. Again, it's really weird how they do this, where sometimes they'll give you a really easy problem, and then a super hard problem, and then they'll give you an easy one right after that. There's no pattern to this. Okay, that's easy. What we have to do is figure out what proportion we need again, like usual. So what we have, adjacent over hypotenuse. Adjacent over hypotenuse, that's cosine. Cosine of 36 degrees is equal to 7 over x. But if I do my cross multiplication, I have to swap our positions around. So that's going to be 7 over the cosine of 36 degrees. So that's what we're going to divide out. So I'm going to do 7 divided by the cosine of 36 degrees. And that's going to give me 8.65. And that's what I'm going to put here, 8.65. And how far are we now? We're down to 2 questions left. So far, so good. Number 6, exactly the same thing, except it's opposite over adjacent. Tangent. Tangent of 43 degrees is equal to 13 over x. Excuse me. And once again, we're going to have to swap places. So I'm going to do 13 divided by the tangent of 43 degrees. And that'll give me 13.94. All right, so 13.94 down here. 13.94. Okay, and now the last question. Solving right triangles. We're almost done with this one. Radio tower. The radio tower. Oh, the angle of elevation. Blah, 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 blah. Okay. Let me just draw it out this time. Ooh, wrong color. Completely the wrong color for this background. Go black. Okay. Go here. Go up. Go here. I know I'm going to need the triangles, so I'm going to put them in. Like so. And like so. And fill in what I need to put in. I know that this is going to be 250 feet. It's really more important to put it here than anywhere else. Elevation is 36. Depression is 30. And now we're going to do tangent. Y1 and Y2. Opposite over adjacent. Tangent 36 is Y1 over 250. Tangent of 36 is Y1 over 250, so I'm just going to move the 250 here because we're going to need it there anyway. And Y2 will be equal to, if I use the same structure, 250 tangent of 30. And again, what I did before, I add Y1 plus Y2, it's the same thing as adding these two together. 250 tan of 36 plus 250 tan of 30. I can just do 250 parentheses tan of 36 plus tangent of 30, because that's going to work. It's viable. It's equal to Y1 plus Y2, which is equal to the radio tower. I'm going to put it in the calculator now. So 250 tangent of 36, okay, plus the tangent of 30. That should be enough, really, but let's see what happens. Okay, we get 325.97, 325.97, 325.97, 325.97. Let's see if that's right again one more time. Let's hit it. And we got that right. So we're done with the solving right triangles, and this is the last time I'm going to visit this topic, but between this and the other videos, you should be okay.